Hey, this is Mr. Ng going over the Precalculus Quiz number 211-14, September 19th, 2019, version P. Multiple choice, circle the best solution. Multiple choice, determine if the function is even, odd, or neither. These are talking about symmetry. Remember, if it is, let's do a quick review. If it is equal to the original, then it is even. If it is equal to the opposite of the original, then it is odd. And if it is not equal to the original, and if it's not equal to the opposite of the original, then the answer is neither. You can think of this as two ways. I'm first going to show you guys algebraically, and then you're going to sub in negative x for every x value. That's what you need to do. So this was the big idea here. So you're going to put in negative x for every x value. And then you just go on and simplify. So remember, negative x means there's 4 of these. I'm belaboring the point, hopefully, but hopeful for some. Negative times negative is a positive, so this is a positive, and then this is a positive. Positive times positive is just a positive. So the 4th power. Minus 7x plus 5. Now, if I look at this problem, I look that it's the same, but this is different, and that's the same. Okay, so what I would normally tell you then is, if you, every time you see 8x to the 4th plus 7x plus 5, then you can put in f of x, but this is not the same. So it's not equal to the original. This is what happens if we factor out a negative 1. That becomes negative 8x to the 4th plus 7x minus 5. So here, this is not the original either, so the answer is A, neither. Let's take a look about that graphically. I'm trying to look for something that's a ruler. Just put this quick graph in and then punch that into our calculator. Delete that one. 8x to the 4th plus 7x plus 5. Zoom 6. Okay, so something to the 4th power even degree. So I'm going to zoom in. So I'm going to change my window. X values maybe go to negative 5. Y max to 2 values. So I'm trimming up the sides there. Now I'm going to do the Y minimum, maybe Y negative 1. That's what my graph looks like now. Pretty good, right? So let's kind of sketch that. Now it's not quadratic. Remember, just a quick review. This is to the 4th degree, even degree, not even symmetry. Even degree, like x to the 2nd, which would be opens up, ends up. And the big idea there is that the a value is positive, so it's going to start up and up. And then if it was even, it would be symmetrical about the y-axis, which it's not. If it was a odd symmetry, even symmetry, symmetrical about the y-axis, on symmetrical about the origin, which means you can rotate 180 degrees. That's not the case. That's why the answer is neither. All right, number 2. Given this function, given the functions f of x equals x squared minus 8 and g of x equals negative 5 minus x, determine an equation for the combined functions h of x equals f of g of x. So we talked about going from right to left. And we're going to put the g function put this in red here. The g function is going to go into the f function. Okay, so let's just see if we can color code this. I'm going to put f. Here's my f function. So let's write out the f function. X squared minus 8. And whatever g is, here's g, put it in red. I'm going to put that into that one right there. Do you see why I left a blank right here? So I'm going to now write -5 minus x right here. Right there. Okay, then I just need to simplify. Now, common mistake here probably is going to be a student trying to distribute the exponent to what's inside the parentheses. And that's incorrect because that only applies to the law of exponents. Like if you had something like this, then that would be x squared, y squared. But the only way you can do that is because you have factors, multiplication. You have subtraction there. So this part right there, you're going to have to do, I like to do the box method, because remember there's two of them. And you would not be so wise to multiply just the first and the last ones. You have to use FOIL or the box. You use the box. If you use FOIL, it's the same thing. You multiply first, and then you combine like terms or add. So -5x, -x, -5, -x. And then I'm just going to go ahead and multiply. So +25, 5x, +5x, and +x squared. You can write any order you want. So now I'm going to write them in descending order. 5x plus 5x, because we just multiply. Now we're combining like terms. So now we're going to add. So that gives us 10x plus 25. And then here's a common mistake. It's forgetting about that -8. So let's put a -8 right there. So that would give us x squared plus 10x plus 17. And then I'm looking for this one, and then the only choice we have there is A. A is our correct answer there. Remember, if they ever ask you a function like domain, then I can just graph this and then get the domain, and then find which one is more strict, most restrictive domain. Question number 3. Find the horizontal asymptote of the given function. So there's a couple of rules that we need. All right, so let's write the rules for the horizontal asymptote if you don't have that in your formula sheet. If the top degree, something like n, is smaller than the bottom degree, call that m, then your horizontal asymptote is always going to be always y equals 0. And then if they are equal, the degree or the exponent, then your horizontal asymptote will be y equals a divided by b. Basically, we said reduce. And the third one is if the top degree is greater than the bottom, then your horizontal asymptote is none. And you might most likely have a slant, which I will not teach you in this class. Okay, so let's look at this problem. Now, the degree here, the highest degree, so this is a 1. Let's just help you understand exponents. X to the 0. So the 2, I like to write that. So my top degree is 2, and then this one here is a 1. So I don't care what's in the front. I will later if I need to reduce, but it's just 2 and 1. And then what inequality can you put in there? That would be greater than. And then match up your signs. Then my horizontal asymptote, when it is greater, you will have none, which is choice C. So keyword horizontal asymptote, just look at the degrees. Let's look at the next question. Question number 4. Given the functions f of x equals negative square root of x plus 2 and g of x equals x squared minus 2x plus 7, what is the domain of the combined function? And if you take a combined function of k of x equals f of x minus g of x. So here's my work here. So let me just show it to you. Hopefully it looks really nice, color-coded. You like that? Okay, so what is the domain? Domain are x values, and we're going to work left to right. So I graphed the red one. And if you put that in your calculator, the square root button is down here by x squared, so it would be negative, not subtracting, second square root of x plus 2. And I'm going to close my parentheses, and then zoom 6. And there's my graph, and then you can do like second calculate. You can find the x-intercept, 0. So to left bound, can you go to the left, and to the right bound? And what's your guess? Try to guess it exactly. No change in signs. Well, you can always look at your table of values. Let's quit, second table. And then there you can actually just see it's negative 2, 0. How do you get the domain graphically? Well, you're going to go left to right. I just want to know if there are x values on the graph. So if I go here, there's nothing, nothing, nothing till x value at negative 2. And then the last thing I touch going left to right is the arrow. Now pay attention, the arrow, although it is going down, a common mistake is to think it's negative infinity. It's positive infinity, and here's the reason why. We're just talking about x values. Does the graph keep going in this direction? The answer is yes, so that would be positive infinity. So bracket or closed circle means you actually got a value, and then I could pick any value that is greater than, essentially this means greater than negative 2, greater than or equal to negative 2. So this is my domain interval notation, and this would be inequality. Let's look at the orange one, quadratic, you should recognize. And if you graph it, it looks like this. And then all you need to do going left to right is arrow to arrow. Anytime basically you have arrow to arrow, negative infinity to positive infinity is your domain. Regardless that it's pointing up and up here. Don't put that positive infinity. Remember, with positive and negative infinity, you're always using parentheses. And then you're looking at which one is the most restrictive domain. Which one's the most strict? This parent over here says you can go anywhere. This one says you can only go bigger than negative 2. So this is more strict. And if you look at our choices, x is greater than negative 2. It's that builder notation, just looking right there. All values of x such that x is greater than negative 2, and x in the element of r, which is all real numbers. So pick all the numbers, but you must be bigger than or equal to negative 2 is your correct answer, C. That was for question number 4. So let's count up the points. 2 for your name, 2 here, 2 for the multiple choice, 2, 2, and then that one is out of 10. Let's turn to the back side. For your response, make sure to show all your work and box your answers. You weren't penalized for not showing box your answers here, but hopefully it's legible. Match the graph by writing the appropriate basic functions, or I was going to say 12 because there are 12 basic functions, in the first blank, so get the name. And then the equation or function in the second blank. Let's look at the first one. Here, question number 1. What you have here is it starts at 0, and then it ends back at 0 at 1 period, what they call. And this kind of looks like a sideways S, and this would be the sine function. So sine function, and then y equals sine of x there. Okay, number 2. Here you have a graph, and this one is called the logistic function, and the equation is y equals 1 over 1 plus e to the negative x. Question number 3, you can call this the log function. Natural log would be acceptable. Natural logarithmic function, and it would be y equals ln of x, or y equals log x. would be acceptable. And the last one here is a u, so that would be quadratic function y equals x squared. Use the graphs provided in question 5 above. Which of the graphs are bounded below only? Bounded below only. So here, this one is bounded because it keeps oscillating, which means it keeps bouncing back and forth. So this is bounded above, a bounded below. This one is bounded. Bounded means both. Again, bounded above, a bounded below. This is bounded. So questions 1 and 2 are bounded. Number 3 here is bounded above only, because this graph keeps approaching there. Keeps not touching it, but keeps going down. So this one's above only. And then this one is bounded below only. So the one that is bounded below only is number 4. Question 6b, which of the graphs has even symmetry? Even symmetry basically means reflected about the y-axis. Remember my silly phrase, evenly? So we just want to be able to fold it on the y-axis. This graph is not over here, so we have no graph over here, so it's not this one. This one, if you repeat this sideways S here, that's what I was trying to show you in the, see how close I can get, the red and the orange there. I was trying to show you that if you reflect it over this way, you should have a mountain right there, but you don't. And so it's not symmetrical about the y-axis. And then this one down below, again, if you folded it over there, you would have a graph up here, but you don't have it below. So the only one that is symmetrical evenly, that would be number 4, which would be just a quadratic. Question number 7. So here we're asked to graph a piecewise function of 2 pieces. And what we have here is, notice that they both have the same boundary. So these are the restrictions in the domain. And the restrictions you kind of want to graph. So what we did is, it's a vertical line here at 1. And we got lucky because it's the same number. So we're going to have 2 pieces going in opposite directions, never in the same direction. This one, remember f of x is just a fancy way of writing y. So you can say all your y values are -4. So let's graph the orange one. This is the orange. All your y values are -4. And then you can make up any x values and graph that. So 0, -4, 0, -4, 1, -4, 2, -4. And what's even better is the numbers that you're picking for x are greater than or equal to 1. So I should have picked 1, -4, 2, -4, 3, -4. So it's a horizontal line, and what's wrong on my graph is that it's an equal, so it should be a closed circle. Closed circle. And the reason why it's going towards the right is because it says values that are greater than or equal to 1. So if you put your pen down, where are the values greater than the 1? So those are 2, 3, 4, and 5. That would be to the side to the right. That's why my graph is to the right, and I'm erasing everything to the left. Another cheesy way of thinking about it is that the inequality, or the variable, is on the left. The inequality is pointing towards the right, so then you want your graph going towards the right. Here you have a linear equation because it's to the first power, so this is y equals mx plus b, and this would be a slope of 1/1. So the invisible number in front of the x is just 1, and then you make that a fraction, 1/1. So my starting point is -1 here. There's my graph. And then what I'm going to do is, my slope is rise of 1 over run of 1. So up 1, right 1, up 1, right 1. And what you're going to do is at 1, the boundary, it is an open circle because there's no equal sign there. And I want values that are smaller than 1. The smaller one on the x-axis would be something like 0, -1. So my graph's going this way. And so what you can do is, your graph's going to go that way, and then you can just erase this one. Okay? So there's our piecewise function, linear and constant. I'll show you how to put that in the calculator. Put in the first function, you just put in -4. And I'm going to put those in parentheses, so -4. And then here's something different, divided by x, and then I need the test button. So test button is right there where math is in blue, so second math. And then we're going to type in greater than or equals to 1. Close the parentheses. Let's go down to question number 2. X minus, or you can subtract 1. I forgot to put those in parentheses, so you can just press clear and do it again. X minus 1 divided by x, and then inequality is test, so second math less than 1. Alright, so I have x less than 1, close the parentheses, and I'm going to press zoom 6. And then that's what you needed to graph. Question number 8 is the rational function, and I think, not sure, this might have been the one the same as last year's. Graph the function, make sure to include the asymptotes and table of values. So to find a vertical asymptote, you set the denominator at not equal to 0. So there's the denominator, the down part of the fraction, and there I just set it not equal to 0. I'll take the square root of both sides. The square root of 0 is 0. Remember, take the square root of a power of 2 should be plus or minus, but there is no plus or minus 0, so x is equal to 0. There is a vertical line, vertical asymptote right there in purple, if you can see that. The horizontal asymptote, you need to look at, I'm going to look at the top degree here. There is none, so it just says y over x squared, so that's x to the 0. So you have 0 and 2. You put inequality, that would have been less than, and then that means when it's less than, you're always going to have 1 at y equals 0. So there's my orange. Actually on the x-axis itself, all the y values there are 0. And then to put that in your calculator, let's put it on our calculator. I'm going to do what most students probably did. They probably did 1 divided by x squared. And then let's see what this looks like. Okay, if you got that, and the reason why I did that is because I know some students do that, is they did not use the parentheses. Essentially what that does is 1 over x, the calculator's reading it as this. And then you can cross cancel and then get 1. So that's when the graph has all the y values are 1. But if you did it correctly, if you clear it, and what I like to do is I put parentheses in the numerator and parentheses in the denominator. Zoom 6. And this is what your graph should look like. And we kind of know what this graph looks like, because if you graph these, you have the purple, you have the orange, you have kind of like 4 quadrants here. 1, 2, 3, 4. And you kind of want to know where the graph is. Is it going to be positive values in the y? Because that's totally helpful. And if you do that, let's take a look. You put in your calculator, so I'm just on the home screen, and then I'm going to go to my table set, so second window, and take a look here. I just want to make sure that the values are counting by ones. You can start at any number, probably preferably around 0 or whatever, and then automatically generate numbers for me, and then automatically get my answers. Or if you want them to pick, you want to pick the numbers, you put ask, press enter. So second table. Let's copy down this table of values, so there I have it. And how do I pick these numbers? How do I know which numbers to pick from my table? Well, if you think about it, let me show you a visual. This purple here is the vertical asymptote. Can you kind of see that? This direction? So numbers to the left of the purple line, are negative numbers. -1, -2, -3. And the numbers to the right of the vertical asymptote are positive numbers like 1, 2, and 3. And so if you copy down those numbers and then you graph them, let's graph these. So -3, 1, 2, 3, and then up 10 cents. The $1 is the whole number. -2 up 0.25, so that's higher. And then -1 and then one whole dollar. So you would have, your graph's going to look curving up there. What this tells you is if these y values are positive, then the graph on the negative side is going to be above and not below. Same thing on the right side. 1, 1, and then they just get smaller and smaller. 25 cents and then 11 cents. So make it curved, and then that's your graph. So let's count up the points. I got 2 points, 1 point per each blank. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 points over here. And then over here, 2 points apiece, so that's 4, 4. So, and this one is 4, so you're 12, 20 points. And then 20 plus 10 in the front should give you 30. Hope this was helpful for you.
Math.
Say it again.
Our math.